center. Center. No rotation. Okay, let's test. Check 1, 2, 3. All right. Hey, today we're gonna talk about more more about Instant Center today. So today we're gonna learn more about what is Instant Center and how to find Instant Center. So first, last time we mentioned Instant Center is a point with zero velocity, right? And what other things instant center can do, or what are other definition about instant center? So instant center is not only a point at zero velocity, it is also the center of rotation. So we mentioned rigid body can rotate, right? There's rotation. If there's rotation, it must rotate about a point. Even it's moving in at a curve, the curve could have instantaneous center. It's called central curvature. So instant center is the center of rotation. And why it's called instant center? It's because that center, it's only at a given instant or moment in time. So which means a point can be instant center, which means has zero velocity, it's a center of rotation. Maybe only true at that given moment. The next moment, position changes, speed changes, and that point may not be the instant center anymore. And instant center, the point can be on the rigid body, it can be also outside the rigid body. And another thing about instant center is if there's no rotation. For example, the rigid body is traveling at a straight line and it only has pure translation. And when that's the case, the instant center, it's at infinity. So keep that in mind. If instant center is at infinity, that also means the rigid body has no rotation. It's doing pure translation. Okay. Those are the main concepts about instant center. Now let's look at some examples. How can we find instant center? So I find a couple examples from your textbook. Let's look at those examples together. All right. So first example is in your textbook 2A7. So make sure you go to your textbook, find this example, look at the diagram. Okay, here in example 2A7, we have a bar AB. This is our rigid body. Both end of the bar AB is resting on the wall, and another end is on the floor. And there's no friction on the wall and on the floor. Once you release this rigid body AB, as you may imagine, this AB, this bar gonna slide, fall down. It's gonna lay flat eventually. So, but at this moment, we're looking at where's the instant center of this rigid body AB. Okay. It is pretty easy to look at. So first question, where's the center of rotation? At this moment, where's this bar is rotating about? If you couldn't see that, let's go back here. So since we're talking about rotation, right? If you have rotation, you're gonna have an instant center. So for example, particle P is rotating about a point. So it's traveling in a circular motion. It's rotating about point O, right? And so if you know particle P is traveling about point O, and point O must be the center of rotation based on what we have here. If point O is a center of rotation, and point O must be the instant center for particle P at this instant. So this is our instant center. Point O is our instant center. If point O is the instant center, what would be the direction of motion for point P? And you probably know that if point P is traveling, rotating about point O, and if you draw a line in between the center and particle P, and the direction of velocity must perpendicular to the line between P and O, right? No matter where the P gonna be, for example, after 5 seconds, P gonna be here, and we can use the same method to determine where's the velocity of point P. So connect point O and P, draw a perpendicular line. That would tell you the direction of velocity for P, Vp, Vp. Okay, so now let's look at this example together. And so we know velocity direction gonna perpendicular to the line that connects either point A or point B to the instant center. So first, let's figure out what is the direction of motion. So where is the direction for velocity vectors? And in this case, we know point B is probably gonna slide to the right, point A gonna slide down. So those are the direction, velocity direction. VB, VA. Okay, so to determine where's the center of rotation, we can simply draw lines perpendicular to the velocity. Let me use a different color. Let's draw a line perpendicular to the velocity at point A. That's a purple line. Let's draw another line perpendicular to velocity at point B. Okay, now you find out we have an intersection here. That is our intersection. This intersection, it's our instant center. So this is the instant center for rigid body BC. So that's how we figure out where's the instant center for this bar at this moment, based on the direction of motion at 2 points, A and B. So now if you compare this with our particle in circular motion, with this particle in circular motion rotating about point O, and no matter where that particle P is, if you connect point P to point O, the velocity always perpendicular to that line OP. So let's look at here. So if we connect point A to its instant center, our velocity at point A always perpendicular to that line A to the instant center. Double check for B. Yeah, connect B to the instant center. That line is perpendicular to the direction at point B. Yeah. So that's how we figure out the instant center. Now let's look at one more example. See if we can use a similar logic to find out where's the instant center for AB. In this case, we have three rigid bodies, right? So let's first point out the easy instant centers. So here we have point O. The disk is fixed at point O, so it only rotates about point O. Of course, point O is the instant center. Make sure you label this for which rigid body. For the disk, you can label that as disk, or you can label that rigid body OB. I will put OB here. Since we have three rigid bodies here, we want to differentiate them. Okay, now let's look at this rigid body just for A. It's block A. This block A, it's sitting on a flat surface, right? What are the possible motions for this block A? That's, for example, if we rotate this disk, what are the possible motions for this A? So this A, block A, gonna go either to the left or to the right. Right, so the motion is on the horizontal direction. Okay, and are there any rotations? No. there is no rotation for this rigid body A. It's doing pure translation only. So we know the instant center for A, it's at infinity because there's no rotation. Okay, now we have one rigid body left. Rigid body BA. Hey, BA, where's the instant center for this rigid body BA? Okay, so instant center is the center of rotation at this moment. And can we use something like this we did previously to find the instant center for BA? Yes, we can. But first, you need to determine what is the direction of motion at point A and what is the direction of motion at point B. So let's first confirm A either going to the left or right. Okay, so we know that. Yeah, so we can leave A alone. Now let's look at B. What is the direction of velocity for B? This is B. It's attached with this disk. So this disk is rotating about 1.0. Same as B. B is also rotating about 0.0. Okay. So what's the direction of velocity at point B? If you're not sure, let's take a step back. Remember this example? Particle P is rotating about 0.0. Then we can easily figure out what's the direction of VP, which should perpendicular to point P to 0.0, that line. So they must perpendicular 90 degrees. Same here. B is rotating about 0.0. So 0.0 is instant center for B at this moment. If you connect BO and your velocity vector should perpendicular to that line OB. So it's either going to go up to the left or down to the right. So that would be our VB direction. Okay, now we know direction of velocity at point A and point B. We can start to draw lines perpendicular to those velocities. So first line, we draw a perpendicular line to this VB direction, which in other words, just extension for OB. Make sure that's 90 degrees. Okay. Line, it's first line. Now let's look at A. Let's draw another perpendicular line through A. So 90 degrees between the line and its velocity direction. As you can see, these two lines gonna have a intersection somewhere. So intersection happens to be up here. At that point, the intersection is the instant center for who? It's only for this rigid body AB. So that's the instant center for this rigid body AB. So at this moment, rigid body AB, this bar, it's rotating about that point. Okay. All right, let's do one more example to make you feel more comfortable about this. All right, now let's look at this example 2A9. Here, we cannot have three rigid bodies, OB, AB, AC, sorry, cannot four. You can treat this C as a block that's moving up and down against this wall. So we cannot have, let's see, three. You can treat this bar and this block as one rigid body. because they're not moving relative to each other. So let's first find out all the easy instant centers to see if are there any points that's fixed to the wall, to the ground. So first, we have that point O. That's our instant center. If that is a fixed point, that must be an instant center for a rigid body who's connected to that point. So the rigid body we have here is the OB. So point O is the instant center for rigid body OB. Now let's look at where's the instant center for this rigid body AC. AC, what are the motion for AC? Is AC rotating? ACs can only move up or down along the wall. So the instant center for AC is at infinity. Okay. So now we have one more rigid body to figure out its instant center, AB. We don't really know where's the instant center for AB. Okay, let's follow the same logic as what we did. Where's the direction? What's the direction of motion at point B and point A? How to figure out that? Start with the easy one. Point A is part of this rigid body ABC. It can only move up and down, so up or down. That's day A. Okay, so we have one direction. Another point, point B. What's the direction of motion look like at point B? Okay, it's pretty easy to figure out because B belongs to this rigid body, OB, and we know the instant center for this rigid body is point O. So point B is rotating about point O, and as you know, if it is rotating about point O, the direction of motion must perpendicular to the connection lines between its instant center and that point. So the direction of motion at point O is perpendicular to that bar OB. Sure, you draw 90 degrees. So VB is going in this direction. All right. Once you know the direction of motion at 2 points on this rigid body AB, we can draw perpendicular lines. So the perpendicular line passed through B gonna be the extension for OB. Make sure that's 90 degrees. Then another line is past A, perpendicular to its motion. Okay, we have an intersection right here. This intersection will be the instant center for AB. Okay. So that means at this moment, A and B, this rigid body, this bar is rotating about this instant center. Okay. All right, let's have a summary. How to find instant center if you have multiple rigid bodies or bars linked together. So we have steps you can follow. So to find instant center, we have 4 steps. First step is to find 2 points A and B on the same rigid body. On the rigid body, you are trying to find instant center. Find 2 points A and B on the rigid body. But those 2 points A and B are not just random 2 points. You need to pick 2 points that you are pretty sure about direction of motion. So you must know what is the direction of motion at point A, what's the direction of motion at point B. Okay, then once you have these 2 points, you need to draw lines that's perpendicular to the velocity vector at both point A and point B. So that's what we did here. We draw the lines perpendicular to the velocity vector at point B. We draw a line that's perpendicular to the velocity vector at point A. That's your step 2, those purple lines. And step 3 is to find out the intersections of the lines you just drew from step 2. That means we find intersections of those 2 purple lines, same as the one we did previously. We find intersections between those lines, but not any lines. It's the line that's perpendicular to the velocity vector. Yeah. Then that intersection, it's your instance center for that rigid body. Yeah. So step 4, it's a check. If you don't have intersections, what would happen? So if the 2 purple lines has no intersections, that only means one thing. That means the rigid body is purely translating, which means there's no rotation. If this is the case, the instance center is at infinity. So no rotation, instance center must be at infinity. Okay, those are the 4 steps that will help you to find where's the instance center for a rigid body.